Okay, this one comes from Calc 1. This is, I think it's number 11 in the homework in the book. It's really 4 problems. So here we go. We have the function y is equal to the square root of x, and it's bounded by y is equal to 0 and x is equal to 3. And we want to revolve it around 4 different lines. One is around the x-axis, B is around the y-axis, C is about x is equal to 3, and D is about x is equal to 6. Now the most important thing you want to do on these is draw a picture, because you know what the actual function looks like. The actual function is a square root, and it's going something like this, and then y is equal to 0 is the x-axis, and x equal to 3 is right there. Revolving it around the x-axis is going to look kind of like a top. Looks something like that right there, or an acorn. And pretty simple on the x-axis, because we're just going to evaluate it or take the antiderivative of square root of x squared minus 0. So volume, this is for a, around the x-axis, volume is equal to pi times the antiderivative from 0 to 3 of the square root of x quantity squared minus 0 quantity squared, and that's dx. Upper minus your lower. Here's the upper, and the lower is right here. That's it. And you're going from 0 to 3 because you're looking at it from the x-axis. So you're looking at it as this is the upper, this is the lower, and you're going from 0 to 3. So integrate, move this up. B is equal to pi, and I'm going to go ahead and integrate it, and that comes out to be x squared over 2. I think it comes out to be x squared over 2, evaluated at 0 and 3, which gives us 9/2. Volume equals 9 pi over 2, or 9/2 pi. Now that one's pretty simple because it's pretty straightforward about the x-axis. And that's that one. Now, B, I'm going to take the same thing and revolve it around the y-axis. So I'm going to take the same function. We know this is x is equal to 3. We know this is y equal to the square root of x. So if I'm looking from this direction, and I need to get it in terms of y, so square both sides, and that gives you x is equal to y squared. So this function is y squared, and this point right here, which gives us our point over here, is going to be the square root of 3. So we're going to evaluate now, instead of going from 0 to 3, where we were looking at the x-axis this way, from 0 to 3, we're going to evaluate from 0 to square root of 3 here, because we're kind of, if you look at it this way, there you go, 0 to the square root of 3, just like we did on the x-axis a while ago. So this one is going to be volume is equal to pi from 0 to the square root of 3 of 3 squared. This is the upper minus the lower, just like we did on the x-axis, upper minus the lower. So that would be 3 squared minus quantity square root of x squared dx. Oops, I'm sorry, y squared, my bad. messed that up. Let me just redo it. V is equal to pi 0 to the square root of 3 squared minus y squared quantity squared dy. Because we're in terms of y, not x, because we're looking in that direction. So that's going to give us b is equal to, and I'm going to skip a couple of steps here, and I believe we get 9y minus y to the 5th over 5, and that's going to be evaluated at 0 square root of 3, and that's going to be v is equal to 9 times the square root of 3 minus square root of 3 quantity squared, square root of 3 quantity squared, square root of 3 to the first power. And I skipped a step there, but what I'm trying to do is show you, if you plug in square root of 3 to the 5th power, you can break it up into 2, 2, and 1, which 2 plus 2 is 4. You add exponents. And these two, v is equal to 9 square root of 3 minus, that's going to be 3 times 3 times the square root of 3 over 5. So now we got to get a common denominator. V is equal to, that'd be 45 square root of 3 over 5 minus 9 square root of 3 over 5. And that's going to give us, I think, 36 square root of 3 over 5. And that is the volume around B, or of B, which is around the y-axis. Now, C is going to be around the axes of x is equal to 3. So now we've got our drawing. Now we're revolving around this way. Now the important thing here is that you draw your dy right here. And I'm just going to shade that in because that's what's actually taking the volume. That's our hatching. It's like I told you in class. But you got this over here that you just can't ignore this right here. And that thing's going round and round and round, but this part is not part of your volume, but you have to count it because you have to subtract it out. So this little area from here to here, from here to here, this little length, the length of this dy right here, so the length of it would be 3 minus y squared. And then of course this is 0, so we're not worried too much about that. So y, or v, is equal to, sorry about that, v is equal to 3 minus y squared, quantity squared, and yeah, that's it. So, and it's still from 0 to pi square root of 3. So that's pi 0 to the square root of 3 of 3 minus y quantity squared, 3 minus y squared quantity squared dy. And that comes all the way down to, I'll go ahead and take the derivative of that, use your shortcut number 2. That's going to be v is equal to pi from 0 to the square root of 3 of 9y minus 6y to the 3rd over 3 plus y to the 5th over 5. And that's going to be evaluated at 0 pi over or square root of 3. And that comes out to be volume is equal to pi 9 square root of 3 minus 6 square root of 3 plus 9 square root of 3 over 5. And that comes out to be, if you get a common denominator, 24 square root of 3 pi over 5.